Good evening. Welcome. My name is Choon Choi, and I'm here at the Department of Architecture and Architectural Engineering at Seoul National University. Thank you for joining us today. And now let's just dive right in. I'm thrilled to have tonight's guest, James Carpenter, with us today. Mr. Carpenter is recipient of the MacArthur Foundation Fellowship, otherwise known as the Genius Grant, in 2004. And his firm, JCDA, has been recognized with the National Environmental Design Award from the Smithsonian Institution and the American Institute of Architects Honor Awards, among many others. Over a career that spans more than 40 years, James Carpenter has inhabited a unique position at the junction of architecture, art, design, and engineering. Working with glass, steel, and the light, his studio crafts environments that mitigate the boundary between inside and outside and bring attention to the phenomenological qualities of light. In my view, the results are nothing short of magical in its power to inspire us to see for the first time the subtle beauty hidden within the everyday environments around us. So please join me in welcoming Mr. James Carpenter.
Great. Thank you very much, Charlie, for the introduction. Charlie and I have known each other for quite some time, since he graduated from Harvard, and delighted to have the invitation to come and speak to you this evening. My studio is in New York City, and we are a relatively reasonable sized studio. We're about 14 to 16 people generally. But the practice really started quite a long time ago. It started back in 1979, following a period of time when I was really working more in the art world in the United States, in New York, and also in Europe and Germany and Switzerland. And the fascination of my studies began with architecture and sort of moved during my university period to a more focused interest in sculpture and particularly working with materials and glass specifically. And gradually sort of came to the realization that I was interested in this idea of trying to capture events in nature, what we observe or perceive perceptually around us when we're in a natural environment, and how one might transpose those qualities of light and experience into more concrete built form rather than simply a gallery installation. And then subsequently over the last 40 years, 45 years, the trajectory has sort of moved from doing smaller scale interventions, collaborating with architects, to opportunities where we've been doing some of our own buildings, certainly over the last 15 to 20 years. But just to give you a little background that frames really the foundation of how we tend to work. Not getting the advancing to go here. To give you an idea of how the projects began, and this is going back to the early 70s, mid 70s, these films that I was doing at the time as sort of installation sculpture would try to take an event in nature that we might observe and find a way to bring that event into sort of a museum gallery situation where you would observe the qualities of light in that event in a very different way. So this is a river in Washington State, and you can sort of see that there's this trajectory of film frames moving up the river. We basically built scaffolding over the river and a series of film cameras down to the surface of the river. And then the cameras basically captured this sequence of the river itself and the movement or migration of salmon as they sort of swim up the river to spawn every fall. And this sort of phenomenon of migration has always sort of fascinated me, and I wanted to find a way to bring it to a different context. So taking the films and slightly altering the timing of the films, you can begin to change how your eye reads the information in front of you. So instead of just looking at this as a film of fish swimming up through the river, you begin to realize that this transparent body of the water not only allows you to look through it to the bottom of the river, but see the fish within it, but also this image of reflectivity on the surface of the river, which in fact is the view of the sky overhead. So by altering the film slightly, you're able to sort of extract particular fields of information and make them more legible to the viewer. So in a way, it's a migration, but you've altered it slightly, so you're seeing a slightly edited or heightened level of information in it. So these types of films were shown throughout Europe and the United States in the 70s. Some of them exist in museums in Europe today. But towards the latter part of the 70s, early 80s, I began to want to slightly move away from the gallery world, where you're just doing these installations sort of temporarily, and find a way to build projects on a more permanent basis. So people might experience them not necessarily being preconditioned to go to a gallery or museum, but find these structures, in a natural environment. And this was a commission we worked on for a family in California. But the reason I show this is it's directly related to that salmon migration. It's a glass bridge floating over a river, and it's accessed from these two different sides. Like you're accessing the river from the two shores. So you move out on one of these gangplanks onto the glass platform, and then move down the glass platform to the opposite side and cross the river. So the whole notion here is that you're sort of creating a situation where the qualities of light within that environment are sort of heightened and more deeply experienced by your engagement with it. But most importantly, having a different sense of engagement with this particular ecology. So it's a way of trying to heighten your awareness of the environment that you're in just by focusing your attention on a few selected characteristics in the surrounding landscape. So the reason I show the films is that those ideas are really underlying many of our projects. I mean, not particularly migration or that particular bridge idea, but just the notion of how do you find characteristics of nature that exist around us in an urban situation, and how do you bring people to a point where they can experience it in a very unique or different way. And some of these projects like this one, which was done in Australia for the Olympics, is a little bit different. You're looking at a bridge again, but it's a bridge that is bringing the pedestrians and people entering into the Olympic arena area, which is on your right here on the far right corner of the image. And the mass that you see rising up out of that river are the content of our work. And what's going on here is a simple diagram, the pedestrian bridges you see on the left, and then these tall masts, they're about a little over 100, 120 feet high, coming up out of the river. And the top 12 feet of each of the masts actually has a misting system in it. So we're taking water from the river, cleaning the water, then putting it under pressure, pushing it up the mast, and then misting it out the top of those masts that you see on the left. And then in the distance, what you see on the right-hand side of this image is what's called a heliostat, which you see up here. And it's basically a mirror that tracks the sun all day long and then bounces a controlled beam of light back through the mist. So it's a very controlled beam of light all day long. It's always in the same alignment. And what that does basically, or what we're trying to do here, as shown in this little mock-up, we're actually sort of testing this whole idea near our studio. But you're taking the sunlight that's coming down, hitting this mirror, and this is a filtration mirror. So all the blue light is passing through the mirror, and only yellow light is moving back and being reflected through the mist. This is the mock-up of the misting mast in the foreground. And this is the whole idea, is like, how do you take light in the middle of the day and make people aware of its presence? Because that's the whole issue of working with light. It's with us all the time. The light is always around us, but it needs to have a surface to sort of reveal itself. And in this instance, we're trying to have the light be realized when it strikes this mist or synthetic cloud that's coming out of the top of these masts. So this type of project is really, here you're sort of seeing the mast being installed on the left-hand side in the river, and then the installation of the heliostat here with the men up there installing the mirror. And then you sort of see this piece in operation, which is the mirror in the distance, picking up the sunlight, and then that beam of light coming back through the mist. So depending on the quality of the day, whether it's like a high level of humidity or low level of humidity, this changes dramatically. And obviously during the windy day or less windy day, it's quite different. So some days it behaves much the way you're seeing it here, where you're getting fragments of the light appearing in the sky. So you're getting fragments of the light hitting the mist here, giving it a sense of sort of discontinuity, you might say, running through the air overhead. There's a sound coming from the misting system, so it's like a low hissing sound overhead when you come through here. So sometimes it appears the way you're looking at it here, or it can be literally a bar of solid light, like you saw in the mock-up. It can be a bar of solid light that can be up to 1 kilometer long, moving across the landscape. So it's really a way of introducing people to that presence of light that you normally associate with clouds overhead, bringing it down to an experience that's very close to you. And a very different type of project, but again, coming back to the cinematic ideas I showed you earlier, this is a small residence built in Minneapolis with Vince James, who is a colleague and friend who brought us into this project to work on all the glazing of the building. And in this project, there was one window in particular that you can see here, up here on this, it's marked there with that little red square. You can see here that doesn't really have a view. And I think that's the whole thing I'm trying to communicate here. That windows, we typically take a window for granted, that it's a piece of clear glass, you're looking out, you're seeing whatever the view may be, or like most windows, maybe it doesn't have a view at all. And this particular window is looking at a stone wall and a fence. And this family was very concerned about privacy, and you can sort of see the other windows have a very detailed system of louvering that can be shut down, wood louvers that can shut it down, can shade the whole house, provide privacy. But that one window that you see on the stairs, we wanted to do something which is essentially addressing that problem, the problem of a window with no view. How do you actually introduce an idea that allows the window to establish a new view of your relationship to the outside? So what you're looking at on the left-hand side is a little mock-up, and the elements of the mock-up are, okay, a blue element indicating the sky overhead, clouds in the sky represented by the little squares, a lens sitting down in the window frame itself. The window's about 30 centimeters, 25 centimeters deep. A series of lenses that are in the window frame itself, and then a mirror set back behind the window frame that actually brings the image like a periscope down into the window plane. The lens reads the images off the mirror, and then by using a piece of diffuse glass in front of the mirror, you can then see that the image is projected and resolved on the glass. So what you're looking at on the right-hand side here is really that same window, little detail. In the background here, very subtly, you sort of see a full image of a tree in the distance, treetop of it in the distance, maybe 30, 40 meters away from the window. Then you see the shadowing of leaves from that tree falling on this window. And then you see the mirror bringing the image down into play. So it's an idea where a window, here it is under construction. You see outside there's a fence and another building right there. And then this is a window on a very bright day. It basically looks like a series of video monitors. In the wintertime, like this time of year, like if you got a full moon like we have here tonight, it'd be a completely black window plane and you'd see 80 images of the moon. Or you get this type of effect, which is the normal reading of the window, where you're having a juxtaposition of sort of projections of the actual view outside, small images of shadows from that tree being projected against the window, and then these pinhole cameras, which are being made by the leaves on this tree in a distance. So it's really trying to collect information from outside. It's the reality of what's outside your window, but it's then allowing this device to collect that information as the sun moves, overlay it, compose it, basically collage it together. So you're having almost like an augmented view or an augmented reality. It is reality, but you're sort of reassembling what's happening outside the building to create a new reality, which is something we're still trying to work with a little bit. It's a very common problem, certainly in Seoul or New York. Probably 90% of the windows don't have views. So what do you do in that case? Here in New York, this is the Hearst Building. This is a Foster project that we worked on. And obviously, it's pretty clear. It's like an older building built in the 1920s, here, late 20s. And just go back, old building, and it never had a tower built on top of it. So Foster was commissioned to do that. A series of large clerestory windows here that established the lobby, the upper lobby, the new lobby for this building, and a series of skylights that were part of the original scope of work. And then this is the entry to the building. So the issue here is entering a building where you have a relatively limited entry that would normally be a very dark space inside. So taking this configuration, this is just a very simple section drawing. This is that archway on the street that you just saw. This is the original historic entry, section through the historic facade. Actually, the beginning of the new building, the new structure inserted down into the original building. And these two diagrams describe what we're trying to do. And the reason I put this in right after the window I just showed you, this also works with a periscopic device, but a completely different scale. So when you're looking into the building, you're essentially seeing this inclined surface. This is a periscopic surface made up of prisms. And they basically are taking the light or the sunlight or sky brightness outside, bouncing it and projecting it to your eye out on the street. So when you look in the building, you're effectively seeing the same brightness that you have out here on the street, the same brightness. So it's balancing that sort of contrast that we typically have. And then simultaneously at the top of the building, taking the water that's being collected from rain on the top of the building, bringing it down. There's a mechanical room back here, purifying the rainwater, chilling it, and then running chilled water over this surface. So this is in fact part of the cooling system for this large public atrium building in this new tower. This now tower is about 10 years old, or 12, 14 years old at this point. But anyway, this is just a little bit of how we do some of these projects. This is a mold made out of graphite, and you're filling it with molten glass. You end up with a casting like this. This casting is at this point maybe 1500 degrees Fahrenheit, 1800 degrees Fahrenheit. It's being allowed to cool down before being removed from this mold that you see here. All the detail you can see on that casting is in that mold. And this is the mounting hardware is all designed into the casting, and that the mold itself looks just like it's made out of graphite and machined to create this prismatic surface that you see here. The men basically just take a casting, set it in place. It's really just supported on both ends. It's spanning this whole different distance, and they can walk on it. It's very, very strong. You can support about 3 tons of weight. So the men can walk on them, and they simply position them in space. And they are triangular in cross section. So they're prisms. So even though it's clear glass, you can't see through this. Like what you're looking at is really the backside of the clear glass surface. So it's a prismatic design, meaning that the light is being captured and bounced out of the glass prism to create this sort of very dramatic sort of effect of light and sound. So the level of water increases or decreases based on the number of people that are entering the building. And that both sound increases and decreases, and the cooling effect both increases and decreases. And then this is the final version when you walk in. So it's basically something that everybody that enters the building experiences and has that moment of time where you leave the city behind, move through this, say, cascade of water up to the upper lobby, and then go to work. So I think it's a very welcome experience for people in New York to have that connection to something outside the city, a sense of environment. This next project I'm going to show you is this small building down here. This is Broadway in Manhattan, World Trade Center site over here. And I'm going to show you some images of this tower that we worked on, which is World Trade Center Tower 7. But first and foremost, show you this one, which is more recent. Started in 2004 and then finished around 2018. Long time project, sort of held up by the basically sort of the recession that we had in 2008. These are our first drawings. This is a below ground subway system, our subway system, which primarily runs north-south on the island. So these are all different subway lines running north and south. And this is the one large room that all people using these subway lines come into to transfer. So the whole idea here is how to bring light into this building in a way that you experience the sky essentially in a way you don't normally have a chance to experience it in the city. So what's important to look at here relative to working with daylight is this is the opening of the skylight right here, this fixed dimension. And the blue triangle you have marked out here is if I look up, the view of the sky is framed by that opening. So I'm only seeing a particular portion of the sky through a typical skylight. But if you begin to shape or change the configuration, like this toroidal shape that you see here, you begin to shape the curvature or the quality of the surface material around the skylight. When I look at this angle, I'm actually looking out at the sky way over here. And vice versa, if I was to look at this section of this curve, I'd be looking at the sky way over here. So what it's saying simply is that you're opening the opportunity of more sky brightness and view to the person below ground to come into this space. So these are mock-ups of the piece, and it's highly perforated, and it's made out of what's called an optical aluminum. And it's perforated simply because in the subway system, as certainly in Seoul as well, should there ever be a fire, there are certain places where smoke evacuation systems are installed to sort of evacuate the smoke, so people are not caught in an environment that's smoke filled. And basically, this whole shape I just showed you is what's called a smoke reservoir. The smoke comes up into that shape, and then it's exhausted through this perforated skin to the outside of the building. And then this piece is really a cable net structure. It's a two-way cable net, and the men are attaching parts of it to a temporary ring, hoisting it up and attaching that to the compression ring at the top of the skylight, as you see there, and then tensioning it down to the first floor of the building. And then they begin to install these panels. So it's very lightweight structure. We do a lot of these sort of cable structures, both with glass and other materials, but it gives you this opportunity, as you can see here, on the far side, it's very highly reflective, although it's a diffuse reflectivity, meaning that it's not a mirror, but it holds the light, the surface quality that holds the light and can hold an image. So if you're in the space, you don't see through it the way you are here, the way we're looking at these men that are in the foreground. You can see how you can look right through this. But if you're looking at it from below, it looks as if it's a solid surface. And what's happening here, that curvature that I spoke to you about a moment ago, what's happening is you're in this space. This is a work platform, so this gets removed down below and it goes down 2 stories down to the subway system. But these are actually clouds. This is a cloud. This is the blue of the sky outside, another cloud. So effectively what it's doing is it's actually taking the sky image and it's folding the image of the sky into the building with you. So if you spend time here at certain times of day, you can see this. You can see sort of clouds moving in the space with you or changing color with sunrise or sunset. It's not true at the middle of the day where there's too much light, but if you're there at those earlier morning hours, late afternoon hours, you can start to see these types of effects. So this is exactly what I said about the films that I began this talk with, which is here's an event that's happening all the time outside the building, something we don't normally pay attention to in New York, but here it is, it's sort of brought in, and it's actually made to be the focal point of your experience and the experience of 300,000 other people who go through this station every single day. So it's an ability to create almost like a collective experience that people all come in and they sort of look at it and sort of, you know, it's just something that everybody sees every day, and it's a very interesting thing to do, and it's a goal of much of our work. How do you find these opportunities to change people's experience of their day-to-day movements around the city? In that same neighborhood, roughly, like we were just looking at a project over here on Broadway. This is World Trade Center Tower 7, which we were very fortunate to be involved with. This is it in plan. This is the formal World Trade Center site, the original super block that had the two towers that collapsed in 9/11. This building also collapsed in 9/11, the original building, and it encompassed that whole site. And then Skidmore, the architects, David Childs, and the original planning move was to reopen a street that had been closed for the last 30 years, a very critical street relative to New York City. It's called Greenwich Street right here. And the significance of Greenwich Street is that it was originally the coastline of the island of Manhattan. So it gives you an idea when you look at everything to the left of that street, that's all landfill, everything over here. But anyway, opening that back up left this building a parallelogram, which obviously has some singular qualities relative to working with light. And the shape of the building began to help define how we would basically establish the identity for this building, as being the first building built after 9/11. The whole idea was to how does this building respond to the quality of light in New York City, particularly downtown New York, where we have a lot of moisture due to the East River and the Hudson River surrounding the island, and be a building that basically gives back to the individual on the street a reading of these qualities of light that are around us. So this is just an idea that we have in our studio that we feel is quite critical, that buildings, there's a reciprocal responsibility for designing the building for the individuals or the occupants. We're working on great quality workplaces, you know, great daylighting to make those spaces comfortable and productive to work in. But there's also, we feel, the reciprocal responsibility the building needs to give back to its neighborhood, having consumed obviously a great deal of sky plane view, particularly in downtown New York where it's so crowded. So building into the building these light responsive characteristics, which I'll show you. So the lower part of the building is a power substation. So these are large transformer vaults. The reason this building went up so quickly was the power substation was destroyed and it had to be rebuilt as quickly as possible afterwards to restore a lot of the power in downtown Manhattan. And we were brought on to basically conceptualize how this building could be this entity that deals with light in a very unique way. So this is a drawing of the base of the building you just saw, all concrete. It needs to be 50% open to deal with the heat that the transformers generated. So it's a naturally ventilated facade. And it also has to be blast resistant, meaning that these transformers can't explode and you don't want them to come out into the street where they're pedestrians. So this drawing is a drawing that is created by, if you were putting your back to the front of the building, looking down the street to your left or down the street to your right, where do we have available light? In New York, a lot of our available light comes down the streets or down the avenues because the buildings are so densely packed. You don't get a lot of direct light directly on the face of the building. And then you have gaps in the building profiles opposite you, where you actually have gaps at the skyline that introduce light. So this is basically a diagram of available light opportunities from the surroundings of the building. And the way they're developed in the sense of the building skin, this is a double layer skin. The outer skin is made of these stainless steel prisms that you can see here. Some are organized parallel to the face of the building. Some are organized slightly rotated to the face of the building. So you can see if light is hitting these, light on this bay here is bounced a certain direction. Light hitting this adjoining bay bounces a different way. And then inside this skin, an LED system here, which is illuminating this inner skin of the building. This depth that you see here is the depth of the curtain wall system. This is the depth of the mullion above. This is about a 9-inch, 10-inch deep mullion. That's the depth of the curtain wall up above on the occupied floors. And we're using it here on the power substation to create something we refer to as volumetric light. When we think about working with daylight, it's not so much light just hitting a singular surface, but allowing light to strike multiple surfaces and actually begin to interact with one another. A little bit more like how you see light in nature. You're always seeing light in nature, seeing millions, if not billions of surfaces illuminated, all different levels of illumination. And your eye sort of composes that complexity, which is happening over a deep depth of field, into a very complex sort of reading of the world around us. It's not a monolithic surface we live with. We're living with a very complex surface. We try to work with that idea of volumetric light in many of our projects. So here's the beginning of that skin going up over the concrete bolts that you saw before, just testing it out. And here it is on the corner of the building. And this is just a demonstration of what it does, just that rotation of prisms, as I mentioned before. These alternating or presenting an image of what's behind one, looking at the building at one angle. And this is the view of what's behind you at another angle. So the whole building is basically just giving back to you the quality of light that's surrounding the building and surrounding the neighborhood. And then the other thing that happens here, even though this is 50% open, your eye doesn't read that because of the brightness on the surface here. It's totally open. If you walked up to this, you could look right through it, but your eye tends to read it as more solid surface. But this material, which is stainless, and this again, something I mentioned previously on that project, is we seek materials that allow for information, visual information, to sort of reside on the surface. You want the color and the imaging to be on the surface, like the clouds you saw inside that other building. This is basically a sunset over the Hudson River behind us. So you're basically just looking at the horizon line here behind you. So you want a material that's not polished. It's not a mirror by any means, but it is reflective and diffuse at the same time. So it's a little bit more, comforting to look at, and it holds more information. So this is at the corner of the building looking up, and the transition of the power substation, which stops here, and then the curtain wall above it. It's about a 50-story building. And this again is this cross section of that artificially lit skin at the base. And that's what this is in the evening. It has a whole program to it that sort of has a quiet moments and a little bit more active moments. There are cameras here mounted on the building. They actually look down at the sidewalk. And then every once in a while, like every 45 minutes in the evening, whenever you have people walking on the sidewalk here, basically the individual triggers, the camera reads the sidewalk, and then there's a bar of blue light that comes up 80 feet here. And they basically are bars of light that are moving back and forth across the face of the building, which basically just talks about the street activation being broadcast into a broader, deeper part of the city surrounding the building. So if you see those bars moving up here and you're 4 or 5 blocks away, it's just telling you that the street activation is happening down below. And then the curtain wall, again, this is the same depth of the mullion that I showed you below. And this is the spandrel section of the building, which is made up of not this exact material, but a corrugated material, finely corrugated material that has that same characteristic I mentioned, a way to hold light. And then the glass on the curtain wall, the full-size sheets actually overlap the spandrel section. So this is obviously the structural bay of the building, occupied floor up here. and the ceiling of the office below here. And in this spandrel area, we've introduced a reflector, a blue stainless steel reflector here. And the clear glass actually goes up. It doesn't break here. You would normally break this in a curtain wall and have a mullion, but the double glazed unit goes right past the floor and up to the ceiling condition that you see here. So these are about 14-foot tall panels of glass, unbroken. And what that does is it means that when you read the sheets of glass on the building, it looks like they're not shingled, but they're just sort of look like they're layered, descending down the building with this volume behind it. And what this is doing is shown here. This is the blue sill that you see down here. Sunlight is coming down, hitting the blue sill, and it's bouncing blue light back up into the shaded part. You're getting sunlight on the top and shadow below. But in this instance, you're pushing daylight back into the shadow, and you're creating this blue lit volume. So this is actually sort of blue light in here. And the whole point of that is that when you look up at the building sometimes, this blue color actually merges with the blue of the sky behind the building. So sometimes it looks like the glass is just sort of floating against the blue sky behind it. But this volumetric light principle that I was talking about is shown here, where you're reading certain information on here, the sky overhead, movement of clouds, and secondarily, there's another quality of light behind it. So regardless, as the sun moves through the sky, both of these things are moving and changing in different ways. So it's constantly presenting the existing conditions that are with us all the time in a way that can be rather startling. I mean, it can be where every one of these lights up from certain angles as a daylighting reflector, or they can be much subtler and do that, what I said before, where the blue sky merges with it. This is a smaller building that we did many years ago in Tokyo, in Ginza. And it's working with light in a slightly different way. I mean, this is Ginza, so as you're all aware, there's a lot of neon around, and these are normally really brightly lit buildings. We wanted the building here, and sort of went for them, and several buildings we did for them in Asia, to be more like a much quieter, sort of almost like a lantern, like a Japanese lantern, or much like a traditional lantern in Korea. And the building has a prismatic field of glass elements on the facade. This is south facing, and then a large glass facade over here with those same prismatic panels inside. So retail inside, 3 floors of retail, restaurant, dining here, a gallery, and then boardroom, offices, and then the rooftop is for fashion shows up above. So the diagram of the building, and some of the glass here in my studio. You can sort of see our studio behind me here. It's more of a workshop where we have full-scale mock-ups of different projects here that we test sort of empirically in the studio before they make their way into projects. And then here you have the exterior, the south-facing elevation, where that same prismatic glass you were just looking at, and this is something you don't realize often, but even though the glass is transparent, because of its prismatic conformation or cross-section, the light is hitting it and bouncing out. So it's a clear piece of glass, but it's a shading system for the face of the building, just because of the prismatic nature. And this is the other side of the building where you're looking through the clear glass and seeing the prismatic surface of these same panels of glass on the inside. So it's very quiet. These are the prismatic panels here. You can see it's transparent, but you're not getting the intensity of light that you would expect coming through that glass. And then this is the space in between the panels where you can see out, and just sort of the interior quality of light in the building. A couple last projects here to share with you are this project, which we worked on over the last few years, and a project that has a lot to do with and this is a project, obviously, one of the first urban national parks. I mean, obviously, our national parks are Yellowstone and all the famous parks that we have. They're out in nature, preserving nature. This is one of the first urban national parks, which was trying to preserve a portion of the Mississippi River shoreline here. The Arch, the St. Louis Arch, which you're probably all familiar with, designed by Eero Saarinen. Small museum underground, designed by Saarinen. These are the original entries to the museum here at the base of the arch, or exits out of the museum. And then the original landscape done by Daniel Kiley, greatest, actually, to my mind, landscape architect from the 50s and 60s, working with IMP and most every famous architect at the time. And this is a competition led by Michael van Valkenburg, a landscape architect and firm that we love to work with. And we were on the team with him. And the team was, Michael's scope was obviously the redoing the entire park, which is about 70 acres. And most importantly, trying to connect the park to downtown St. Louis. A new bridge here that was put in to cover and get rid of surface roads that were here, 2 lanes of surface road and parking, 2 lanes of surface road and parking, 6-lane interstate highway. So basically 12, 14 lanes of traffic to get from downtown St. Louis into the park. Very stoplights everywhere to get across it, very noisy, very uncomfortable sort of sense of arrival. So this is a major thing to sort of build a bridge over the highway, redevelop this park that you see at the top of the image to connect to a historic courthouse that's to the north there or to the west. And then our part of the project was to basically excavate this museum that had been underground for 50 years, re-waterproof it, and then build a whole new entry and then put it all back together again. So this is a diagram of, this was the original thing underneath the arch here, Mississippi River Arch. New construction here, all new construction, excavation underground, coming up to a new entry here, covering that highway, getting rid of the surface roads, and then making a new park, and then connecting to this historic courthouse. So basically a civic monument or civic courthouse, historic civic courthouse here, and then our new sort of civic space created as an entry here that you see down below, bringing you into the below ground spaces of the arch ground. So Saarinen and Kiley, very beautiful, sort of sinuous, very generous, sort of organic means of moving people through the park ground. So we really kept that sense of movement, kept that sense of movement with the new entry, moving people around, coming together, moving away from each other, coming together again underground, and sort of bringing this back to a restored state. So here is what you were greeted with previously, sort of rundown park, surface roads, parking here, big 6 lanes of highway underneath here and a trench, and surface roads on the opposite side, and then just getting across traffic lights and all of this to get to the park. And then the original model shown here of this, and then this is our model here in the studio that I'm in right now, just showing this new entry, new below ground space. We weren't allowed to put any skylights or anything in the ground. We were able to excavate the ground and then put it all back at the original conformation, sort of the topography that was there, and then the renovation, expansion of this museum underground, and then the exiting down here. So now you enter here, security, wayfinding, information, descend down, new exhibits in the museum, and then everybody exits down here, down below. And then the little covering the highway you see here, getting rid of these surface roads, bridge going in, beginning of the excavations, restoration of the whole park. Here's Michael restoring all the trees, replanting all the trees in the park, all the shoreline of the river being restored, new paths being put in and planted, the new entry sort of in the landscape you just saw taken apart. And then looking down from the top of the arch, seeing that same condition we were talking about, this whole highway surface road problem being changed, the changing this park, and then connecting to that courthouse in a more seamless way. So quite a large project. And then here in our studio, developing the lighting idea of how to light this below ground space so that it felt as if you're in a daylit space and not an underground space. So we do a lot of these things in the studio, like trying to full scale, trying to build parts of a system. And then here it is, part of the below ground space, mezzanine below ground. People are moving, cut into the wall here, moving down, going into the museum below here. So very active area. And then the entry, which is proven to be sort of quite a big civic space for educational purposes and just gatherings of different meetings and celebrations. Everybody sort of moves around this circumference here. You enter through the doors on each side. You're descending down, and then you enter into this area. So again, tucking a fairly significant new space and architecture below ground without changing the conformation of the landscape. And then obviously huge celebrations there every year, and quite a load on top of the space we built. And then just leaving you here sort of with the last project, and Charlie, we can do some maybe questions and answers via text or something if you wish after the lecture itself. But a project in Palo Alto, California for Stanford University, where you have the Pacific Ocean on the opposite side of these hills, or small mountains. And that's a very moist and cool environment. The Pacific is quite cool in California, water temperature. And then you immediately come over this mountain range, you're into the Bay Area, which is drier, certainly, and warmer than you have on the other side. But you get the fog coming over the mountains and sort of settling into the treetops here in Palo Alto. And we were asked to look at this amphitheater on the Stanford campus. You can see it, the main sort of tower on the Stanford campus here. And this is an amphitheater that's been there since the 1930s, surrounded by, it's almost invisible when you're on campus because it's surrounded by this beautiful forested area of redwoods that you can see here. It seats about 7,500 to 8,000 people. And it originally was where they would have graduations and these beautiful, all these concerts like Grateful Dead concert and Joan Baez, all these famous concerts, and San Francisco Symphony Orchestra. But they wanted to, as the class sizes got larger, it sort of went into disuse or not being used. It lacked handicapped accessibility and general ADA requirements for entering and exiting and seating. Most of the seating is on grass. And any sort of amenities were not there. So we were asked by the president to come up with an idea to cover a space that would seat about 2,500 people, which would be roughly a class at Stanford, or smaller groups, or a graduating class, say from the business school, and provide a way to both prevent rain, but also how one might alter the climatic temperature within this bowl. And by that, I mean a structure which is a deployable canopy, which can be in the summer when you have the sun coming down and overheating this bowl, deploy the canopy during the day so it doesn't build up heat during the daytime, and then retract the canopy at night to let that, whatever residual heat is there, to escape to the sky. So you can actually lower the temperature in summer, and vice versa, the same process, expose the grass to winter sun, and then in the evening deploy the canopy and hold the heat in the bowl. So a little acoustical surface directly over a new stage and a seating area behind the canopy. The canopy sort of deploys out and does it. So here's this whole idea. That little forested area is always shaded up above, so cooler air exists under these trees. And then simply by the deployment and retraction of the canopy, you can create a flow of air that pulls the cool air down. I mean, it wants to settle, but you can actually draw it down and create sort of an exhausting of air out the back of it. So you can actually create a very comfortable low wind currents through there. And I think the thing to note on the canopy, it's working with the engineers with whom we work on most of all of our projects, like Bergman and Partners from Stuttgart, Germany. It's a two-way cable net, very light structure. And being a two-way cable net, we're almost taking the same shape as the topography of the bowl and then inverting it so that this being sort of convexed here and creating this more organic relationship between these two volumes, and then setting the canopy down low so these larger trees are actually quite high above it, so that you'll see what happens with sunlight coming down, casting the shadow on the canopy itself. So this little video tells you pretty much the whole story of how it's designed and how it sort of fits in with its context, which I think is obviously something we try to do as best we can on each project. So there's a clear sort of aesthetic connection. What you see on the cable here, those are not just cables, it's a cable that has a built-in daylighting reflector on it. This amphitheater faces south, which is a little bit unusual, which means the audience is looking into the sun. So this actually bounces the view of the sky behind you. So when you're looking up, you see a bit of shading of the south sky, but it sort of shows the sky behind you, the north sky. So it deploys out, takes about 2 minutes to deploy, and then it's tensioned once it reaches its deployment, and then you can start seeing these shadows cast on it from a bird's eye view. But of course, that's something that you experience underneath here, where you actually have the shadows falling above you. So you feel like you're really embraced by the landscape when you're in the space. And then, of course, what happens in the evening or lighting it. So that's for the last project that I brought and to share with you this evening. And I guess I'll just sort of close by sort of reiterating a couple of things that I've mentioned. As a studio, we're very focused on materials and using materials very particular, in a very particular way, a very specific way relative to how they respond to light or how they're used structurally in a project, and always being conscious of light control in the more generic way in terms of, you know, shade and protection and the heat, thermal gain or protection against thermal gain, but actually trying to work with light in a way that creates an event or an experience that is quite unique and it's a little bit unexpected when you're entering into a space. For instance, in that St. Louis Arch project, we actually have sunlight that can get over 100 meters underground. You can actually go right through that entry and penetrates all the way down into the museum. That was one of the prerequisites that we sort of started with. We said we wanted to have light get as deeply underground as possible. And then you also have, from the deepest part of that museum space, you can look back out and see that dome on that historic courthouse in the distance. Or in this instance, the light is being used to sort of create this new environment, this new space within this outdoor stadium space that sort of makes it feel more intimate and sort of creates a very unique quality of space to be sort of held within. So there's that whole thing about managing light and the materiality that goes with it. And as the films I showed you and many of these things, even this project, they all have a component of sort of cinematic properties where, you know, the movement of the shadows and the trees overhead, I mean, trying to actually always bring about an awareness of these things that we take for granted in a city or take for granted in many places, but they are all, we think, very important things to remind ourselves of that there is this sort of shared or collective appreciation for qualities of light or experiences we all have in nature, and how do you sort of recoup those or refine those to, you know, have them be manifested in unexpected ways, sort of within our urban experience, and not rely on just digital representation of those things, but have them be the real thing. It's actually is what's happening, and it's being made more significant in its presentation, or its presentation to you as an individual. So I will leave you with that. And just to say, I guess also for students, just something I always try to leave people with, my own trajectory in terms of my practice, as I sort of mentioned early on, went from studying architecture, went to the Rhode Island School of Design, got involved in materials, interest in materials and glass in particular, and structures, and then was doing film installations as an artist, and then sort of came back into architecture sort of through that trajectory, sort of like through the art world and then back into architecture, collaborating with architects on smaller scale projects, and then eventually projects, say, of this nature, the front of you, or the St. Louis Arch, where we're actually doing the work ourselves. But it's never a planned trajectory from my perspective. It's always using opportunities that arise, use them wisely to explore your ideas, and use them as a way of sort of educating yourself about your own ideas. Like what is it that can be done at a smaller scale, and then bring it into these larger type projects gradually. So you've had a period of projects, smaller projects, to experiment with something, explore it, and then deploy it at a large scale at a later date. So I always think of ourselves as just being very opportunistic in our opportunities, and that's led to, you know, these things that I would have never expected we would be doing. But that's the fun of it.